heat and phase changes. What this is talking about, when it talks about phase changes, it's talking about that heating curve that we were looking at on the last worksheet. And we're talking about the phase change from solid to liquid or back, and from liquid to gas or back the other way. And it gives us two formulas here in order to figure out what amount of heat energy it's going to take to either freeze or melt a substance or boil or condense a substance. So remember that for freezing and melting, we're right here at our boiling point, and our melting point, I meant to say, and here we are talking about boiling and condensing at our boiling point. So when this happens, you have to add energy or take away energy in order to change the state of matter. The amount of energy that it takes is called the heat of fusion here at freezing and melting, and the heat of vaporization at the place of boiling and condensation. Now, what this tells us, this heat of fusion, tells us that for every gram of water, in this case, for every gram of water that we have, it takes 340 joules of energy to change that 1 gram from a solid to a liquid, because we're talking about heat of fusion here, which is at our melting point, so from solid to liquid. The heat of vaporization, however, says that for every gram of water I have, it's going to take 2,300 joules of energy to turn it from a liquid to a gas. Here's our heat of vaporization. So it takes 2,300 joules of heat energy to raise 1 gram of water by, to change 1 gram of water from a liquid to a gas. So that's a lot of difference, and you can see why it doesn't take as much time to melt ice as it does to boil water, because it takes a lot more heat energy that we would have available to use like in our kitchens to boil water than it does to melt it. So in these problems, you're going to use these two formulas to solve here. And the reason you're going to use them is that you're not always going to be changing 1 gram of water into a liquid or into a gas. Most times we'll have more than just 1 gram of water. So we're going to use these formulas to figure out how much total we would need by multiplying the heat of fusion or heat of vaporization by the actual number of grams that we have in our substance. So here it asks us how many joules of heat are necessary to melt 500 grams of ice at its freezing point. So since we're talking about melting, we'll use this formula here. Mass in grams times the heat of fusion, and we'll look down here for our heat of fusion. You are going to get some rather large numbers on some of these, and that's perfectly normal because it does take a lot of energy to melt or boil water. Now when it asks how many kilojoules is this, I want you to remember that kilo means 1,000, so it's asking how many thousands of joules is this. So whatever answer you get here, how many thousands of joules is your answer? All right, the other ones are very straightforward. You're just going to tell how much heat is necessary. All right, how much heat is necessary, how much heat is given off, and then on this last one, it's going to ask for the mass, and it gives you the joules of heat. So make sure that you put your heat where heat belongs in your formula. Put it on the left-hand side of your equal sign, and then solve for what you're trying to find, which in this case is mass. So if you get stuck on any of these or still have any questions, please come ask.